Hey everybody. Um, this is actually what we're going to start off with. I know I've already made a few comments about how important it is to keep your binder in order and that big stack of paperwork in order, but I figured on one of these off days here where we're not doing this live together, I thought section 1.2 might be a better section to kind of do first here via a video completely on your own. You're going to be taking all the notes that I do because you're going to be turning in, this notes handout on Google Classroom. So, and I figure this would also be a pretty good lesson to kind of make sure we know how to do that. Again, like in the early stages of this semester, I not only want to cover section 1.2, but I want to use this as a way, as an assignment to kind of also check to make sure we all can turn this in correctly with a PDF and all that kind of stuff. So here we go. Take these notes along with me. So before, I'll give you another like 5 seconds here, but get out this paper. Again, it's a little bit out of order, but section 1.2, adding and subtracting rational numbers. This is the notes. You will be turning this in, so kind of like take these notes exactly as I take them. And here we go. So adding and subtracting rational numbers. With section 1.1, when we do that together, you'll get a better idea of like what the word rational means. Maybe you already know what rational means, but not going to get into that right now. This is just about adding and subtracting rational numbers. So obviously 3 plus 4 is 7. 9 plus 13 is, oh gosh, I'm getting a little nervous there. 22. 6 plus 8 is 14. That is the kind of adding you've been doing since, like, I don't know, second grade, first grade. Finding the pattern here, negative 3. Oh no, negatives. Negative 3 plus negative 4 is actually negative 7. Negative 9 plus negative 13 is negative 22. Negative 8 minus 8 is negative 14. Okay? I want you to understand that this is the same as negative 6 plus negative 8. In other words, adding a negative number is the same as just subtraction. So here, negative 9 plus a negative 13, that's the same as just doing negative 9 minus 13. I hope you know that. But you're adding two negatives, they sort of combine to be like, negative 7. So here, like negative 6, and then you're minusing 8. You're at negative 14. I usually go into more detail with classes, but I think I'm just going to emphasize more, than my usual routine, is just to kind of, I'm going to really more emphasize the fact that you should always just use your calculator if you have any doubt. If you're not the greatest at mental math like this and like working with negatives, you really need to make sure you are using a calculator to be sure. 3 minus 4. Again, that's the same as doing 3 plus a negative 4. You should get negative 1 and negative 4, okay? And negative 2 for that one. Okay? A positive 6 and you're adding a negative 8. They kind of clash, and the net here is like, negative 2. Negative 3 plus 4 is 1. Positive 4 and positive 2. Again, if you don't understand these really well, you need to have a calculator handy. You should have a calculator handy anyway, like all the time. But here, like a negative 9 adding 13 Okay? Imagine if like you start at -9 and then you add 13, you're going to the right and you end up at +4. Okay, now something I want you to notice here. When you have a double negative, like 3 minus a -4, that's the same as just saying 3 plus 4. You should understand that. Minusing a -4, you might as well just say +4. So this answer is 7. Likewise, 9 minus a -13, you might as well just say 9 plus 13, which is 22, I believe. And then this is pretty much the same as 6 plus 8, and so 14. Again, you should be writing down these exact same notes that I'm writing down for you to turn in a second. A quick definition: the opposite of a number is its additive inverse. So a little vocabulary here. Now, spoiler alert, I prefer the word opposite way more than I prefer additive inverse. Because a little bit of like, I don't know, just kind of like the inside scoop or whatever. The word inverse, okay, like if I was able to kind of talk about right now the big picture of high school mathematics and all the definitions and like that, the word inverse can be kind of tricky, you know what I mean? We use the word inverse in a lot of different situations. So I don't like to kind of emphasize how it's an additive inverse. We just like to use the word opposite. And the opposite of 4 is -4. So that's what we mean, The opposite of a number is a number that is like the same distance from 0 on a number line. It's like just the opposite sign. So the opposite of -9 is just 9. The opposite of 7 is -7. So that's opposite. And again, you could also call it additive inverse, and you wouldn't be wrong. What do you think here? This is something I wish I had you guys live for. The sum, for you to answer this, the sum of a number and its opposite is always what? It's like another way to sort of define opposite or additive inverse through like what the sum always is. What's the sum? When you take a number and its opposite and you add them together, what are you always going to get? Like 4 plus -4 is 0. So it's another way to define what an opposite is. You take a number and its opposite and you add them up and you always get 0. So that's actually section 1-2, technically. And let's cover, because 1.2 and 1.3 are sort of together. So you have, what you're going to be doing is basically like turning your paper over, because 1.3 notes, I think it should just be on the back of 1.2 notes. So here we go, going, back to second grade a little bit, but, also mixing in high school with negatives. Find the pattern. 3 times 2 is 6. 5 times 7 is, that's right, 35. 12 divided by 6, that should be 2 if I'm not mistaken. And 9 divided by 3 is 3 again. That's just going back to like second grade, maybe third grade. No tricks there because it's like a +3 times a +2. Again, like you've been doing since like second or third grade. Hopefully knowing your times tables. But again, if you're kind of weak on your times tables, that's unfortunate, I have to say. But you should always have a calculator handy because at the end of the day, you just want to be correct. If you are a little shaky on 5 times 7 being 35, that's okay, I guess, at the end of the day. But don't get it wrong, when you're doing other problems because you refuse to just get your calculator out and make sure you're correct. It's better to be correct than to have all these times tables memorized. But anyway, 3 times a negative 2, a positive 3 times a negative 2, that's going to be negative 6. Just like that's going to be negative 35, and this is going to be negative 2, and that's going to be negative 3. Because, spoiler alert, I'm saying this a little bit too early, maybe, in this notes, but if you're multiplying or dividing two numbers and they have different signs, like, a positive times a negative, or here like a negative divided by a positive, the final answer is going to be negative. If the signs are different, final answer is negative. Signs are different. You should know that rule. Like, you're a little bit handicapped, so to speak, even though you do have a calculator handy at all times, hopefully. It really helps to understand and know these rules. But when the sign is the same, like a positive times a positive, or a positive divided by a positive, just like here, a negative times a negative, if the signs are the same, the final answer is positive. So, okay, a negative times a negative, the final answer is positive. Just like, and division is the same thing. A negative divided by a negative, the final answer is positive. A negative, again, negative divided by a negative, there we go. Okay? And then a quick property. For every non-zero real number, so basically anything other than 0, there is a multiplicative inverse. Okay? I think what goes here is 1 over a, right? Such that a times 1 over a equals what? A little bit of dramatic pausing here, sorry. But, because I kind of want to say this. Just like on this other paper, how there was like this fancy vocabulary word with like additive inverse. But remember how I said the word inverse is a little tricky. You got to be really careful with the word inverse. We like to use the word inverse in a lot of different situations. So sort of maybe the more common word for additive inverse was just opposite. Well, guess what? Multiplicative inverse, that actually has like another word that we actually like to use better. If you know it, it starts with an R. So a multiplicative inverse we also like to call reciprocal. Okay? Multiplicative inverse, but I'm probably going to use the word reciprocal more. Or as I like to sometimes refer to it for fun, whatever, refliprical. And maybe you know why that's sort of a neat way to describe it, but I don't know why, but this is bothering the heck out of me right there. Okay, so reciprocal, or like I like, to be cute, I like to say refliprical, because, you flip it basically. Like you'll see here in these examples, like 7 and 1/7 are reciprocals, okay? They are multiplicative inverses, okay? But again, I like the word reciprocal. So 7 and 1/7, kind of, like a and 1 over a very general sort of textbook-like definition. But here's a good example, 7 and 1/7, okay? Another example would be like 2/3 and 3/2. Those two numbers are reciprocals of each other, or reflipricals. Get it? Flip it. The flip of 2/3 is 3/2. Anyway, so these are reciprocals, okay? I could give like billions of other examples, like 7, oh my gosh, how about 17? And 1 over 17, or like 3/5 and, 5/3, whatever. Like, obviously there's an infinite number of them, really. So, again, what is like so to finally finish off this definition, the actual definition of a reciprocal is that when you multiply them together, like you can't just say, oh, it's the one's a flip, you flip it, right? And by the way, 7 and 1/7, those are flips of each other, because isn't 7/1? You bet it is. So, yeah, I mean, you could think of it as like, oh, it's the flip, like when you flip it, it's the reciprocal. But the actual definition is really more like how when you multiply them together, what do you get? When you multiply two numbers that are reciprocals together, what do you get? What's this times this? What's this times this? What's 7 times 1/7? What's 17 times 1/17? 1. When you multiply two reciprocals together, you should get 1. You always should get 1. Guess what, guys? That's it for that video. You're going to be turning in. So again, like what I'm hoping for is you take a couple pictures. Hopefully you can compile it into like one PDF file, and you're going to be turning in that. And you're also going to be turning in, the homework. Like I think it's called 1.2, 1.3 repetition. So a couple like PDF files you're going to be turning in, from this lesson. But let's see how this all goes.